Have you ever gazed at the night sky and wondered, do we share this vast universe with other life forms? It's a question that has sparked human curiosity for ages, leading to the relentless search for extraterrestrial life. This quest has taken us beyond our own solar system, into the depths of the cosmos. We've turned our gaze to distant exoplanets, hunting for signs of life or biosignatures in their atmospheric compositions. This scientific endeavor is as complex as it is fascinating, and it often stirs up intense debates. One such place of interest is K2-18b, an exoplanet that has been at the center of some heated debate. K2-18b first piqued our interest in 2015 when it was discovered by NASA's Kepler spacecraft. Situated over 110 light-years away in the constellation of Leo, this exoplanet emerged as a tantalizing enigma. It was roughly twice the size of Earth and possessed a similar rocky composition. Quite intriguingly, it orbited within the habitable zone of its parent star, K2-18. This Goldilocks zone is the sweet spot where conditions might just be right for liquid water to exist on a planet's surface. In the earlier stages of exploration, K2-18b was thought of as a potential Earth 2.0. The optimism was fueled further when observations suggested the presence of water vapor in its atmosphere. An exoplanet with water? That's a cornerstone for life as we know it. This discovery had us all on the edge of our seats, hoping that maybe, just maybe, we were not alone in this vast universe. However, as we delved deeper into the study of K2-18b, the picture became less clear. With further examination, K2-18b began to show its true colors, and they weren't as Earth-like as we'd hoped. Diving past the initial excitement, the cold, hard data began to paint a different picture. The exoplanet, once thought to be a potential Earth-like world, started to resemble something quite different. The verdict? K2-18b is more akin to a cold Neptune than an Earth twin. Now you may wonder, what led to this drastic shift in perspective? It boils down to two key factors: density and composition. The low density of K2-18b, when combined with its composition, hinted at a planet that was much less Earth-like than initially believed. In the world of exoplanets, these factors are crucial, as they give us important clues about the host planet's atmosphere and potential for life. Speaking of atmospheres, let's delve into another layer of this controversy. The initial observations of K2-18b suggested the presence of water vapor in its atmosphere, a tantalizing hint at the possibility of life. However, further studies revealed a twist in the tale. The supposed water vapor turned out to be methane, not water vapor. A significant finding, considering the implications it has for the planet's habitability. And just when we thought we had enough controversy, another claim surfaced, adding fuel to the already burning debate. This claim suggested the detection of potential biosignatures on the exoplanet. But as we'll soon discover, this too was met with a heavy dose of skepticism. But the controversy didn't end there. A recent claim has further stirred the pot. In an unexpected twist, researchers claim to have detected potential biosignatures in K2-18b's atmosphere. These were not just any biosignatures, but dimethyl sulfide, or DMS, and dimethyl disulfide, commonly known as DMDS. These two compounds are often associated with biological activity, making them tantalizing clues in the search for extraterrestrial life. However, the detection of these potential biosignatures has sparked a robust debate within the scientific community. The reason? The standards for confirming biosignatures are incredibly rigorous. They require multiple unambiguous signatures, a criterion that many argue hasn't been met in the case of K2-18b. The controversy also stems from the complexity of interpreting atmospheric data. When we look at exoplanets like K2-18b, we are peering through layers of atmosphere trying to discern the presence of specific compounds amidst a sea of other elements and molecules. This is no easy task and leaves ample room for interpretation and, yes, even error. Moreover, it's worth noting that similar exoplanets have shown similar signatures. This raises the question, are we detecting biosignatures, or are we simply seeing common atmospheric phenomena that we don't fully understand yet? These questions underscore the need for caution in making definitive claims about potential life on distant worlds, and they remind us of the importance of skepticism and rigorous testing in the scientific process. So, while the search for extraterrestrial life continues, it's important to remember that not all that glitters is gold, or in this case, a sign of life.